ko na. Ayan, hello. Hello, I'm George Mendoza from the PhRUG Group, and this is the ninth episode of the Philippine Ruby Group podcast. Uh, Today, I'll be sharing uh, some tips on testing. Just to give you a background, this week I've been asked to update our website so that we can we can the website can set up priorities for different kinds of states, for the different states in the US. So what we want is to be able to group US states into four priorities. The priorities will determine which group of states gets where do we ship subscriptions first. I'm sorry for the I'm sorry if that was a bit confusing. Should be simpler. Uh, might be I might be able to explain it better by showing you the code, or at least as a copy of the code. So I think this is it. There. It's actually not that. Okay. So what I saw from our app, from our code, is hash states to priority. So we have a hash wherein each key is a list of states, and for those lists of states, what we wanted is to have a method that gets the priority of a given state. So I'll explain that method later on. For now, what I wanted to do first with this hash was to make sure that if I change it, I want to make sure that the changes I introduce do not break things. Uh, However, this hash, this constant hash, tested yet, so I needed to write a test. So how do I do that? Okay, is it good in the first place to actually write a test for a constant? In this case, the constant is something that's used to configure the app. Does it make sense to test some configuration? Generally, we don't need to test constants. If you have a constant and it's set to some array of strings, then usually we can leave it at that. But in this case, we had the the constant, the hash of states to priority was a bit more complex. It had the list of states, and I wanted to make sure that any changes I made to that hash doesn't break it. I also wanted to make sure that all of the states that we add to that hash are valid, and that I don't miss we don't miss any state. We want to make sure that each state will have its own priority. Okay, so for the rest of this podcast, I'll just show three ways we can possibly test this. But you'll see that I'll be recommending the third one. So let's start with probably the simplest way to test it, which is to just compare the with with what we know is the um, uh, com- just compare the hash to itself. Sorry. Okay. Let's share it again. Let's share my screen again. And okay, so here's our main test. Now, supposing we want to test it. Okay. States to priority. And we just test if it's equal to, if this will work. If there's, this will work with should, without should. So anyway, we want to test is if our hash is equal to this known hash, which is valid. That's about it. Okay, let's try if that passes. And it passes. Okay, but is that we want to just check if our production code is the same, or if our test fixture is the same as our production code. Generally, we don't want to do that. If we make changes to our application code, in this case the states to priority hash, we it requires also changing the test, and vice versa. If you make a mistake in changing either, you won't know if which one is correct. So let's try and illustrate that example. Suppose we want to okay. Suppose we want to add the new priority, or we want to separate this fifth priority into another list, something like this, right? But let's say, so suppose this is the new requirement. We have a new priority, and it has this new set of set of states. But suppose that while editing this test, we did something correct. Like, for example, we duplicated the last state, like that. So now if we run the test, we should get an error, right? Yeah, because now our application code is different texture, or it's different from our expected hash. Let's try. We know the requirements. We do the same thing for our application code, but this time we get it correctly. We don't duplicate the last state. sorry, forgot to share the screen. Okay, so here. Uh, so you see in our application code, we implemented the requirement, and this time we got it right. We didn't duplicate the last state. If we run the if we run the test now, we think that it should work because we made the right changes to both. We made changes to both the state and and our app. But in this case, we're getting an error saying that our expected hash doesn't match the application code hash. And in this case, we don't know which one is actually correct. Is it our application? Should our application match the test fixture, or should the test fixture code? So this is why we usually don't want to just copy what's already in. We don't want the test to do the same thing that the application is doing. Okay. Okay. So that's one approach. Another approach that I saw is to a second approach is to what if we just validate the the values of the hash. We just check if they use the right they use the right data types to for the keys and the values of our states to priority hash. So we might want to do something like this. Okay. So instead of application like this, or we can remove that entirely. We can probably say has strings for keys. It has our states to priority has a has an array of strings for each each of its keys, and it has an integer for each of its values. So our expectation here can be something like let's create a subject here, but it will be easier. Here. So we're expecting our subject, each key. We want to make sure that each key is an array, and the contents of that array are strings. Maybe we can do something like this. The things that you usually want to avoid in writing tests is to put your expectations inside the loop. That's another discussion on testing best practice. But for now, let's just do that to illustrate the kind of testing that we want here. So we have our keys. Expect that each one is an array, and that the value of each array is a string. And we can do the same similar thing for the values. Remember, I think that should be it. Uh, let's try this out. Okay, check our terminal, run the same test, and good, it passes. Huh. Okay. So what are we doing right now? We're testing. We're testing if we're testing the implementation of our states to priority hash. We're testing if its keys are arrays of strings, and if its values are integers. Now, what do we know about this implementation? For one thing, uh, it doesn't validate everything that we want to validate on our states to priority hash. Uh, it's a bit it's a bit too permissive because we can try changing. We can new states. We can add if we add an incorrect state, or if we miss out on a state, then we don't know. We don't know. The test won't tell us that the constant is invalid. So, for example, okay, let's try adding some fake states, and let's remove some valid ones. If we run this now, that still passes. So why is this happening? Um, what we're doing here is that we're testing, as I mentioned, we're testing of the hash. We're testing it. Our test digs into the how the hash is implemented. So we know that the test knows that the hash uses strings to represent states and integers to represent priorities. Uh, the test knows too much. What we want is to be able to design the test in such a way that it tests the domain without knowing without knowing its implementation. So we want the test to test. We want the test to test if there are states and there are priorities in that hash and that they are used correctly. But we don't want the test to know or priorities are actually implemented. Um, so that's my reason for failing. So let's try it again. This time we want to, instead of testing for strings and integers, we just test if the keys of the hash are states and if the values are priorities. So how can we do that? Okay, first let's bring this back. Let's try leave it there. Okay. So this time around, we just test for hash states, a list of states for each key, and it has priority for its value. How do we test this? What we would like is to have, let's start with the states. What we would like is to have a list of states that we can guarantee to be correct. So maybe we can look into Wikipedia and copy all the state abbreviations there. And what we would like to have like this, we're expecting our subject, to equal our, wait, we're expecting the keys of our subject. If we flatten them and probably sort them, we want it. We want those states to equal our expected states. Now we need to set up this expected states fixture. And I already done that. I already got the list of 50 states in the US. There. Let's leave the priority for now. Okay. So let's try this test first. See if it works. Okay. I did something not enough, apparently. My expectation is not correct. Let me look at it one more time. I think that should fix it. Try it again. Okay. I'm not panicking yet. Screen share. Okay. I'm sleepy already. Okay. So these are our states. Expecting it to equal this here. Where did those map calls come from? There we go. We're still getting some errors here. Um, our expected list of states are the ones that we got from a valid tree source, a valid source. We know that we assume that they are correct. And our current states, if you compare them, there are a few things incorrect. For one thing, we have some unknown states. We have some states like WI here that are not included here. And finally, we have some states that are duplicated in our output. So let's fix those three errors. There. We go back here. We move back WY. We remove X. And this AL here and there. We just we check our requirements and check what is the right priority for AL, Alabama. And let's assume that it's for priority 1. Now, if I test this, then it should pass. We're getting an error. Sorting. KL. Okay, I see the problem. Our list of states are not sorted, but the ones that we're getting from the application code are sorted. Let's do that. And oh, sorry. So what I did here is just sort our expected states. And run the test. There, guessing. You might be asking, is it good? Is it a good idea to? Is this the same problem as what we had earlier, wherein we're relying on our fixtures to be correct, and as you saw, they were slightly incorrect because they were not sorted, while our expected, while the applic while the thing that we're testing, we sorted. Okay. Generally, what is happening here is that if we look again at the application code, each expected states only once, and we can to our spec, it's possible that to reuse this expected state in other tests. So this way, we only have one source of information regarding what is the correct list of states. We can consider this information very stable because it's unlikely, it's very rare for a new state to be added to the US, and it's very rare for a state to change its abbreviation. So once we get this done, we don't have to worry about it for a long time. If we compare it to previous test, the first one wherein we just check if our subject or if our states to priority is equal to some hash. In that scenario, in that test, we are testing two things. We are comparing two things that are both equally likely equally likely to change because they are one and the same. So that is why we had this situation wherein we had an incorrect test and we had a correct application code, and we didn't know which one of them we should trust. So I'm reading right now Practical Object-Oriented Design by in Ruby by Sandy Metz. And one of the principles of that book is to make sure that whenever you have dependencies, your less stable code should depend on your more stable code. If I apply it here in our test, our our states to priority, our subject, the subject that we are testing is less stable than our fixture, which is our expected states. So this is why I would say that this is a better design because our less our expectation is depending on our the thing that we're testing is depending on our fixture. How about so that's for states. How about the priority? So for here, we can do something similar. Let's try doing that. What we want is that our subject and its values is equal to what we know are the list of our expected priorities. And where can we get these expected priorities? Well, since this is something internal in our business, in our domain, then it's just something that we have to define ourselves. Let's try if that passes. Yeah, it does. Okay, same problem as the one earlier. Uh, in our test, we have unexpected priorities, which is just a list of what we know are the valid priorities in our domain, 1 to 6. Uh, like the first problem is this a case wherein we're relying on our tester knows too much about the application, or is it um, is it just duplicating the code? Uh, One thing that we can say is that the structure, the form of the application code is slightly different. In this case, we don't have an array of priorities, but we do have the values of our hash being values from 1 to 6. So structure-wise, they're different, which is a plus. Conceptually, we can think of priorities as having values 1 to 6. And we can think of them as being stable, at least in our domain. Uh, like our list of states, it's not likely to change, although it's probably more likely to change than our list of states. But still, it doesn't change as much. Our list of priorities doesn't change as much as our assignment of states to priority. So in this case, the rule still applies. The thing that we're testing is amending on something that is more. So the thing that we're testing, which is the values of it's we're testing it on something against something that we know to be a little bit more stable, which is just the list of our priorities. For example, we add a new we redefine our test. We redefine our requirements. So we now have, say, a new priority. Then, in that case, we have to update both the test and the application code. So, but in other cases wherein we just need to reassign a state to another priority, but we don't touch we don't add a new priority or remove a priority, then our test doesn't change. Okay. So this is the test that we eventually ended up with, something similar to this. One thing that you might ask is, shouldn't we also test if the if a list of arrays will match a certain priority? So what you might have in mind is something like this. We're going to use the so and we would have similar tests for for the rest of our list of states. This is something that we want to test. If I run the test right now, it should pass. So not and it passes. But this is a good thing. I would say that this already the it already tests an external API. In this with this particular test, we're already testing uh, our hash's ability to fetch data. So in a way, we're already testing the what they call this the fetch method of hash. This is something that we know to be already tested in Ruby itself. So we don't need to do this. Uh, so how, with this in mind, does the affect this one? In this case, how does our previous test differ from this kind of test? Or another question, rephrasing that question, is this states to priority test testing Ruby's hash? And I think it's not, because it's testing our use of Ruby's hash. It's testing the way that we're using a hash to represent a relationship between states and priorities. We're not testing how that hash works. So I would not recommend having this second test here and just leaving the test to this one. So that's pretty much it. Next week, what I'll show is how to test how some code that actually uses this constant. You'll see some different ways to do that. Again, I'll show what I think is the nicest way to do it. So thank you very much for watching Hangout screencast. I hope to see you again next week. Goodbye.